Algebra 2, 8.6, we're going to solve exponential equations first and then move on to log equations. We are going to solve, so that means we're solving for a variable. It doesn't always have to be x, and most of our problems it will be in this section. Now, there's a couple different ways. When it's just an exponential equation, which means I got two exponents set equal to each other. There's a couple different ways we can handle this. The first way that we are actually going to start off with is we're going to sit back and take a look at those base numbers. And the whole idea here is to get something like this. If I was able to get down to, say, 3 to the x equals 3 to the second power, what does x have to be? It has to be a 2, right? The only way, if the base numbers are the same, that means the only way for those numbers to be the same is if the exponents are the same. So therefore, x would have to equal 2. That's what we're trying to do. But I look at our particular problem. Our particular problem has a 4 and an 8. So what we're actually going to do is we're going to use the power of power rule. We're going to take and use substitution and substitute something in for 4 or something in for 8 or both of them that gets the same base. So you got to kind of think, what number can have a power on it that can give me a 4 and 8? 2. And so I think most of us would agree that 2 squared is 4. 2 to the what is 8? Cubed, or 3. And now we can use power of power. I'm going to take away that example that we are not using now. And now use power of power, and you would say 2 to the power of power you multiply. So 2 times 3x is 6x. And don't forget on the one on the right that the 3 here has to be distributed through. Do you remember that? So this is 2 to the 3x minus 3. And now it looks exactly like our last problem. It just has bigger numbers in it or some other things to it. Hopefully you recognize that our bases are the same. So that means the exponents have to be the same. So 6x equals 3x minus 3. It becomes an algebra 1 problem. You guys can handle that, right? Biggest thing when you're doing this is you should always check your answers. There will be times where your answers will work out here, but then they will not check out. So subtract 3x. I'm hoping you guys are already doing that. So it's 3x equals negative 3. Divide both sides by 3. And you get negative 1. X equals negative 1. That's it. X equals negative 1. And then you check it. That's solved. You've solved it. You found an answer. Now you just kind of come up here and check it.
Solve it.
Or check it for both sides.
Yeah.
So 3 times negative 1 is negative 3, which means it would push it down to the bottom and become 4 to the third power on the bottom. What's 4 to the third power? 4 times 4 is
16.
So it'd be 1 over 64. Then I come over here. What's negative 1 minus 1? What's negative 1 minus 1?
0.
Negative 1 minus 1.
I
Negative 2. What's 8 to the negative 2 power? Goes to the bottom, becomes a positive 2. What's 8 squared?
64.
So it's 1 over 64. That checks out. We're good. That means that's an answer. We're just right, let's check it. So we put x back in and both sides were equal. Remember, when you're checking, you cannot cross the fence, right? The next set of problems or types of problems you're going to deal with is exponent problems that actually equal a number and not another exponent. Basically, 2 to what power is 7? Well, 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. Wait a minute, that's already over 7. So you know the answer is between 2 and 3, right? But what is it? You can guess and check until you get something, but it's not going to turn out to be a nice number. So this is what really cool thing you can do. You can, I picked up in terminology is hit it with a log. We're going to go use that inverse idea. And we're going to use the inverse idea that log base b of b to the x is equal to x. I want my logs to have the bases of the exponent. Remember, what you do to one side, you have to do to the other. So if I take a log of the left side, I need to take a log of the right side. And you always will take the log of the base of the exponent. So what's the base of the exponent? What's the base number on the exponent? 2. So you're going to log base 2 both sides. And it's on the left side of things. Notice that I put it in front here and I put it in front over here. Because what happens with the 2's on the log?
They cross out.
They cross out. That whole side just becomes x equals log base 2 of 7. You're done. Now, you can use change of base. Remember change of base?
No.
We did change of base the other day. That would be equal to the natural log of 7 over the natural log of 2. Or log 7 over log 2. You can actually find the true value. It's not going to be pretty. It's going to be a really long decimal answer. But log base 2 of 7 is the value of x. And you can plug it back in. Now, whatever you use, if you use one of your approximations here, you're not going to get exactly 7. You'll get just over or just under. So just to play on the idea we just did, they give it to you in a little bit more of an equation style where you have to isolate the exponent first before you get rid of it. So use your same exact rules. What would I do first? I got to get the exponent first. Subtract 4 from both sides. So subtract 4 from both sides. 10 to the 2x minus 3 equals 17, right? Now we're basically trying to figure out 10 to the 2x minus 3 power is equal to 17. 10 to some power is 17. Definitely not nice, because 10 to whole number powers end up just being multiples of 10. So, I want to bring that exponent down or get rid of the base number. So I'm going to take the log base what on both sides? 10, because the base of the exponent is 10. These cancel each other out to get 2x minus 3 equals log base 10 of 17. You have options. You can leave it as log base 10 of 17. Wait a minute, do I need to write log base 10? Or can I just change that to log 17? Just log 17, because remember, log is log base 10. It's a common log. So now it just becomes a number. Take your calculator out and figure out that number. We got something like 1.23, and then I can just solve it like normal. Add 3. So 2x equals 4.23. Divide it by 2, and you get 2.15. That seems a little too high. 115. Okay, that sounds a little better. 2.115. And of course, what should you do with this answer? Plug it all the way back into here and you should end up with 21 equals 21. Now we're into the log equations. I call them log equations because they already have logs. If you come across this log equation, you're happy. You're happy because it's log base 3 equaling the same log base 3. It's basically saying 3 to what power is this is 3 to what power is that. Basically, the stuff that's inside is your exponent. Your exponents have to be the same. If it's the same log equaling the same log, your first step would be say, wait a minute. If the logs are the same, that means the numbers inside have to be the same. And so you can just, you can cancel the logs out and ask yourself, when does that happen? Gather the x's on one side, the numbers on the other, right? Add 1, subtract x, 4x equals 8, divide by 4, x equals 2. And you're done. Check your answer though. One key thing that'll help you with this is that will speed things up when checking, is if you take this number that you're putting into the log, if it makes this number negative, it won't work. Because logs can never end up equaling something negative in there. Okay? You can't take a positive number to an exponent and get a negative number. So therefore, on this particular problem, if the answer would have been negative 8, you would say, nope, because negative 8 plus 7 is negative 1, won't work. Logs, you can't take a log of a negative number. Okay? So be careful on that. But it doesn't always happen that it's a log equaling log. Sometimes it's a log equaling a number, just like last time. So, how do we do with this one? They use this long word. It's called exponentiate, both sides. This is using the other property. Remember the one property was if you had a base, wrong way, and the log itself happened to be an exponent, the bases cancel the logs out, and you still get what's inside the log. Remember that? That was like the second property of inverses that kind of worked against each other with logs. So what I'm going to do then is I want to take this log on the left-hand side and make it an exponent. I'm going to put an exponent on something of the base 5. But what I do to this side, I have to do to that side. So it becomes 5 to the power of log base 5 of 3x plus 1, equaling 5 squared.
Wait, where'd you get the 5?
Because I want it to be the same base as this one. Because I want all of that to cancel. Using the property that we just stated here. So that means, when does 3x plus 1 equal 5 squared, or we'll say 25? And I think that's pretty easy to solve, right? Subtract 1, 3x equals 24. Divide by 3, x equals 8. And so, check your work. Does it work? Now, another way to do that is just switch this to exponential. Start with your original problem. If I wanted to switch this, wouldn't this be 5 squared equals 3x plus 1? And that's exactly what we just said here. So you can either switch it to exponential, or we like to say exponentiate both sides. Any questions? No. And the last problem that we'll do is what happens if you have to use your properties of logs first. I've got a log base 10, this is log, of 5x, plus log of x minus 1 is equal to 2. You can't just solve for an individual log. If I'm going to do this, I have to bring everybody together first before we solve. So what's the law that says that I can take two logs when they're adding, I can put them together and I would end up what? Multiplying. So remember, that means the log stays the same, so it's just going to be a log of 5x times x minus 1, right? I'll put brackets maybe on the outside, is equal to 2. I get 5x times x minus 1 inside the log now. And from here, I can exponentiate both sides or switch it to exponential form. And if I do this, I'll change colors so we can see it. It'd be 10. 10, yes? That will cancel out the logs. So we get 5x times x minus 1 is equal to 10 squared or 100. And now you just have to solve it. To solve it, I'm going to need to multiply the left side. What's 5x times x? 5x times 1 minus 5x equals 100. That looks like a quadratic. That means bring everything to one side and factor it. So subtract 100 from both sides. 5x squared minus 5x minus 100 equals 0. A is not equal to 1. Can we make it A equal 1 really easily? What can we do to both sides that'll help us out? Make this smaller. Divide or factor out A. 5. If I divide both sides by 5, well, 0 divided by 5 is still 0. But you notice that 5x squared divided by 5 is x squared. Negative 5x divided by 5 is a negative x. Negative 100 divided by 5 is negative 20. I think that would be way easier to factor, won't you? The only factors to give me x squared is x and x. What are the factors of 20 that can give me a negative 1? Factors of 20 that can give me a 1 or a negative 1.
5 and 4.
5 and 4. One's positive, one's negative, I would assume, because we got to get to a negative 20, right? So, which one's the positive one? Which one's the negative one? Remember, they have to add up to a negative. So 5's negative, and the 4 is positive. That's not solving it, that was factoring it. Now we have to solve it, and we solve it by setting each of those equal to 0. So x equals, first one? 5. Or x equals? Negative 4. When they're nice like that, it's pretty nice.
What about that other 5 that we took out?
That technically, we divided it so it's gone. But we could have said that oops, not there. It would be sitting out here. And 5 equals 0 doesn't mean anything, so you wouldn't have to worry about that. So these are the two answers. I've been telling you all along, check your answers, check your answers, check your answers, right? But why? To see if they can work. Plug those answers of 5 and negative 4 into our original problem. What's 5 times 5?
25.
25. You can take a log of 25, yeah? What about 5 minus 1? Can you take a log of 5 minus 1? 5 minus 1 is 4. Can you take a log of 4? Yes. So guess what? 5 works. Negative 4. Ooh, what's 5 times negative 4? Can you take a log of a negative number? No. Guess what? Negative 4 is out. 5 is my only answer. Boom. You're good to go now. That should help you out.